Hello, this is Sumit Sharma. I am talking of something very important in medical science. That is jaundice. Now, what do you mean by jaundice? Jaundice is a yellowish discoloration of the skin, eyes, and other tissues caused by the presence of an excessive accumulation of bilirubin in the plasma and tissue fluids. The normal serum bilirubin that level is about zero point 0.2 to zero point 0.8 milligram per deciliter, and the clinically means when we have a patient of jaundice, that is when we come to know about the jaundice, that is when the serum bilirubin levels that exceeds 2 milligram greater than 2 milligram per deciliter. Okay, so this is as simple as that. And you can look in this picture, this lady this lady with the yellowish eyes, you can clearly see the sclera, this white portion of the eye. You can clearly see this white portion has turned yellow. What we should know is why we look into the sclera for this jaundice. Actually, sclera is white, so yellowish discoloration is more obvious. And secondly, sclera has a protein, elastin, which has an extremely high affinity for serum bilirubin. Okay, then how bilirubin is produced and what is bilirubin, all these things related with this. Okay, so I tell you what is bilirubin. When RBCs are degraded, a substance is produced that is called as the bilirubin. The bilirubin which is produced or formed by the destruction of RBCs is free or unconjugated bilirubin. It is lipid soluble and bound to albumin in plasma, which prevents its excretion by the kidneys in urine. On reaching the liver, on reaching the liver, the free or unconjugated bilirubin that is split from albumin and enters the hepatic cells. In the hepatic cells, it undergoes conjugation with a compound that is called as the UDPGA, uridine diphosphate glucuronic acid, and it becomes conjugated. So the function of conjugation that is performed by the liver, more specifically by the enzyme UDPGA, and once it gets conjugated, it becomes water soluble. Firstly, it was lipid soluble. I told you it was lipid soluble, which prevents its excretion by the kidneys in urine. But now after conjugation, it becomes lipid soluble. It becomes water soluble. That means it can be excreted via urine. Now, what happens? Excretion of conjugated bilirubin by the hepatic cells into the bile canaliculi is an active process. That is, it is transported against a concentration gradient into bile canaliculi. Okay. Now what happens is, this is the rate limiting step in the liver for handling of bilirubin and needs energy. Some of it escapes into the general circulation and is excreted via kidneys in urine as urine bilirubin, while most of it passes by the bile ducts to the small intestine. So where we have reached now? We have reached to the intestines. Okay, small intestine. When this conjugated water soluble bilirubin reaches the large intestine, it is degraded by colonic bacteria. We know there are commensals or some bacteria which are always present in the intestines, and these bacteria which are beneficial for us, what they do is they degrade this bilirubin. Which bilirubin? It is basically the conjugated bilirubin to form glucuronic acid is split from bilirubin. Basically, the bilirubin undergoes reduction, forming a colorless compound called as the stercobilinogen, also called as the urobilinogen. Okay, some 20% of this stercobilinogen is reabsorbed into the portal circulation to reach the liver. It reaches the liver, while 80% of it is excreted. 80% of is excreted in feces, and stercobilin, some gets oxidized to stercobilin. Brown compound gives brown color to the faces. Okay, now let me summarize this. What happens? This is a very good illustration. See why I am using this book. I am using this book because whenever we upload these videos on the YouTube, people don't, you know, they don't have faith whether it is correct or it's false. So I thought that book would be more appropriate, because book everybody trusts what is written on the books. Okay, I repeat it once again. Once RBCs get destroyed in the body, or in the human body or any other body, then we have the formation of free or unconjugated bilirubin. This is unconjugated. See, it is unconjugated. That means it is lipid soluble, so it cannot be excreted via urine. It's bound to albumin because it is lipid soluble. Albumin is also a lipid, so albumin gets this unconjugated bilirubin. This gets bound to albumin and this enters the liver. For reaching this liver, it takes the help of this albumin. So the function of albumin is the transportation of the unconjugated bilirubin to the liver. Once it reaches the liver, it has to enter the liver. Albumin splits. See, albumin splits, and the bilirubin that combines or compiles with the compound that is called as the UDPGA, that is uridine diphosphate glucuronic acid, and it becomes conjugated. What is conjugated bilirubin? Conjugated bilirubin is basically the bilirubin which is water soluble. Now, what happens is, this is the common bile duct. This is the common bile duct. The bilirubin, see, I mentioned over here also that they are water soluble conjugated. Excretion of conjugated bilirubin by the hepatic cells is an active process. See, I told you that time also, it is an active process. So, and this is the rate limiting step in the liver for handling of bilirubin and needs energy. Some of it escapes into the general circulation, is excreted via kidneys in urine. Some of it escapes into the general circulation. See, it escapes into the generation and is excreted by the some of it escapes into the general circulation, is excreted by the kidneys as urine bilirubin. Okay, as urine bilirubin. See here, urine bilirubin.